Hello and welcome to the ePrime Intermediate Scripting webinar. My name is Rima Malik. I'm a technical consultant here at Psychology Software Tools. Today's webinar is a recorded webinar, so you can follow along at your own pace. You can pause or rewind if you need to go over any topics that have been covered. This gives you the flexibility to design the experiment along with me and do it at your own pace. The first thing I would like to go over is how to stay in touch with us here at PST. We are on all the social media sites, and the one I would like to point out actually is our PSTnet channel on YouTube. There are some great videos on here that go over features of ePrime and show you some different design options that you can do within your experiment. So we definitely recommend checking out our channel on YouTube. The other thing that I would like to point out is our website, if you're not familiar with that. It is, I'll pull it up here, it's pstnet.com. And if you go onto our website, there is a lot of information regarding our products. And if you specifically need to get in touch with a consultant regarding your ePrime experiment or any questions you have regarding your ePrime, you can go to the support tab and then to product, service, and support. And once you click on product, service, and support, we recommend actually logging in up here in the top right corner. That will allow you to register your product information, kind of gives us information regarding who you are and your registered serial number with ePrime. And that's pretty much the quickest way to get in touch with a consultant here. And we also recommend when you submit a support request to us, if you could attach your experiment file and any additional files needed to run the experiment. This allows us to actually open up the experiment on our computer and run it so that we can advise you or consult you on any problems you're having. So definitely attach your experiment, even if it's just the bare minimum and you've only had a little bit of designing done on your experiment. We don't mind at all. We would love to take a look. So this is the way to submit a request. We also have articles on our support site as well as many sample experiments. So definitely browse through our website, and we will be updating our recorded webinars as well for purchase. So if you're interested in those. Now, before I begin into the actual scripting portion of the experiment, I wanted to talk a little bit about the general scope that is in ePrime. If you're not familiar with scripting in ePrime or scripting in general, the ePrime scripting is based off of VBA, so it's the Visual Basic Applications, and we call our scripting eBasic. And if you're not familiar at all with coding, you can definitely look into some VBA books. I know there's a VBA for Dummies and some other resources that can help you with scripting. And then, as I mentioned, on our support site, we do have a lot of sample experiments as well. And we also have a help option within eStudio where you can open up eBasic help, which I will be opening up in a little bit. And that is kind of a huge repository of all the script that is utilized in ePrime. So that's a great resource as well. But the scope that's actually important to kind of note with ePrime is that ePrime can only look up for information. So whether it's a variable or anything set in your experiment, you want to work in the top-down approach. That's why ePrime is designed to have these layers. So the first layer would be the main session procedure. And then you would actually build off of the session procedure. And this kind of just shows you the levels that are by default available when you design your experiment. And it's very important to remember that with attributes, you can set them many different ways. One way is by setting the attribute in Startup Info Editor, which would allow the attribute to be available before the experiment even started. So that kind of just sets the, the age, the sex, the gender, any attribute you would like to put in there. And then you can also have the information entered when you run the experiment, so the participant can put in their subject number or their information, and that attribute would be set in the experiment. The other way, which is more of the interface, is setting the attribute in the trial list, which is typically what you would do by setting either the text or any other images or videos that you are displaying for your experiment. That can be set in the trial list, and then those attributes will be defined and logged into your experiment. This is just going over the object properties. If you're not familiar with the interface, there are many different things you can change about each object that you put into your experiment. So whether it's an image or a text that you're displaying to your participant, you can change the frame, the font, how long you would like that object to be shown, as well as what data you would like to be logged. So all of the things that are referenced in the actual object properties can also be referenced in script. So that's kind of the takeaway of this slide here, that you can definitely customize your experiment by using the interface, but you can also reference these properties in script and customize your experiment and really make it your own by implementing some script as well. These are some timing considerations that we really want you to focus on with script. Of course, with ePrime, with the millisecond accuracy, we want to make sure all of the experiments are running with the best timing practices. So with that said, when script is involved in your experiment, you want to make sure that the generate PreRun option, which is a property available in all of the procedures, you want to make sure that that is set to before object run. And this is something that I'm going to demonstrate when we start actually designing the experiment. But I wanted to point this out because sometimes this will have some designing issues when you run your experiment if you have script and you don't have this set correctly. So you want to make sure that generate PreRun is set to before object 1. And what this basically means is the script will not generate until this object actually is in line in the procedure. So when it's basically the object's turn to be presented to the experiment, then that's the time that it will generate. You don't want it to generate any sooner, because with script you want to make sure that the script is running correctly. So if you run it or generate it beforehand, it can cause, as I mentioned, some design issues with your experiment as well as timing delays. The other thing with timing considerations is pre-release. This is something you set in the duration of your object property. Now if you have script right after this object, you would want to make sure that you have the pre-release set to 0, because again, you don't want the script to be generated in the background too early. You want it to be shown or generated at the right time, such as when the participant responds to the slide or anything like that, because script can customize a lot of these objects, so you want to make sure that it's ran in the right order that you've set it in your experiment. And as I said, we'll talk about this a little bit later when I actually show you in the experiment. We talk a lot here about advanced error handling. These are kind of just practices that we like our users to be aware of. A lot of times we will get participants, people that design an experiment and they have put a lot of script in there, or they've copied and pasted script from another experiment, and they haven't really gone through the scripting process of debugging. So they will get an error message and they will really have no idea why that error message happened, and they get confused. And of course, we don't mind looking through the script and helping on our end. But if you're starting out new with ePrime, we recommend implementing the first portion of the script. So have a design, have an hypothesis, whether you're doing a prime experiment, or if you're just doing a simple stimuli with a response, or whatever your design is going to be. And then start with the first portion, set the script, set the objects up in the experiment, and then actually test it. So even if the experiment's not done, we recommend generating it, running it, and making sure you don't get any error messages before you continue to add any more script. This allows you to debug, basically line by line, which is really the best way to go about designing an experiment, especially with using script, because like I said, you don't want to get to the end and have an error message and you have 100 lines of script. So definitely work by first doing the first portion, debugging it, and then implementing the next portion. So this is kind of just something we recommend with scripting. And even if you're copying and pasting or referencing a sample experiment, you would want to do the same thing by setting it up in the first few lines, generating the experiment, making sure you don't get any error messages, and then continuing with the design flow. Now, going back a little bit to the scope that we talked about, as I mentioned with the layers of ePrime, you can actually see attributes in certain sections. So this is showing where attributes can be seen when they're set. So when you initialize or set an attribute in the session procedure, it can actually be seen anywhere below because, as I mentioned, it's a top-down approach. So if ePrime can look up and find the attribute that was set up here, it can be referenced below. And then if you set it in the block list, so let's suppose you set some text or some stimuli here, it can actually be referenced anywhere below. And same thing with here. So you just want to make sure the attribute is set high up enough that it can be accessed in your lower levels of when the experiment is ran. This shows where an attribute reference can get their values. So if you want to retrieve values from the session procedure, this is kind of the timeline that they can get the values from. And then this shows the same thing of where you can actually get the value at runtime. And before I actually go into the actual topics we're going to discuss today, I want to let you know I will be designing most of the experiment today with you, kind of line by line typing the script. I think that's the easiest way to see how to type out script in ePrime so you can follow along on your end. But unfortunately, with recording the webinar, I cannot run the experiment, but I definitely advise you to go ahead and pause the webinar at any time, generate the experiment, run it, and see what changes have been taken place by implementing the script that we've added. And of course, if you have any questions at all regarding this webinar or anything else, you can submit a support request, and our consultants are familiar with this webinar. So if you have a specific question to something we talked about today, you can definitely submit a request and we will be in touch with you. This is kind of the topics that we're going to mostly cover today. The advanced error handling is the first thing we're going to talk about, and I've kind of broken this up in a way where we will talk about advanced error handling, and I'll ask some questions. Then once we go through the actual experiment and talk about each of these topics in detail, I'll come back to a slide and I'll have the answers to these questions, which hopefully you'll understand after going over the topic. So with advanced error handling, we want to really stress the fact that copying and pasting is really not the best idea for script. If you're familiar with ePrime, you'll know that it's very easy to copy and paste an experiment or a procedure from somebody's experiment and put it into your own. Even with sample experiments, if there's something that you're trying to do that already has a sample experiment available, you can copy and paste a lot of the objects into your own ePrime experiment. With objects, you can copy and paste, change the name, and it's ready to go. Play around with the properties and set them the way that you want. Now with script, a lot of times people will copy and paste, but someone else's script may reference a different object. So you may think that the script is exactly what you need, but the object names may be different. The data that they're collecting in the script, or the statistics that they're tracking, may be different than what you want to track. That's why with script, we definitely recommend line by line reading what is in the script and then copying by just referencing it rather than fully copying and pasting it. Copying and pasting also may not be time efficient for you. There may be settings or some loops or things in the script that could be better for timing considerations, so we definitely recommend looking into that. The other thing that we have with advanced error handling, if you are copying and pasting, or if you just want to check whether a script has been set up correctly, we have these debug statements. So here I have what are debug statements, and when is debug.print used and when is debug.assert used. So these are the two debug statements that we're going to talk about. So I'm going to actually go into eStudio now, and you'll see that I'm opening up a experiment we have that shows some debug statements. And before I open that up, I want to point out the Help tab up here, and also the eBasic help that I had mentioned. This is the repository of all the script topics that are available in ePrime. There's a lot of information in here, but you can definitely do the search engine and find the topic that you're looking for. So if I type in debug in here, you'll see right away you find the debug.print. And if you click on that, it will give you a description of what it is. It will give you comments as well as an example. And in this pretty lengthy example, you can see at the bottom there is a debug statement. So this eBasic help is a great resource if you want to look at something specific in script, and it gives you basically the exact syntax of how you would want to type that into your experiment. As I mentioned, if you need to copy or check the copy and paste that you've done, or if you've gotten an experiment and you're not sure if it's set up correctly, we definitely recommend these advanced error handling options such as the debug statements. Now with debug.print, just as the name kind of says, it will print an actual value for you. This checks whether the script has been executed correctly, and it also checks what variables are going to be returned, and they will actually come out in this output window. So if you see down here, there's an output window at the bottom, and of course when you generate or run your experiment, there's information in here. There is an advisory tab as well with recommendations on how to make your experiment better in terms of design and timing issues. They're not necessarily error messages, but just recommendations that ePrime has on making your experiment better. But you also will have this output window here where a debug.print statement can actually show a value here so that you can check if the variable has been collected correctly. So the example we have here is in the Save Responses tab. So the participant replies to this reply slide, and then ePrime uses this inline script right after, which makes sense because you want to check what the participant responded. And you'll see that there's a debug statement right here. And this allows a warning message to be shown if a duration of a specific time is not met. So if the duration time minus the pre-release time is not 0, then this script may not process properly. And there's a warning message that will print out, letting the person know that there is something wrong. And you can see what the warning messages actually are by going to your user script. So if you go to View and User Script, and this is kind of the global general script that's available in the background of ePrime, we have set here some constants. These are the warning messages that would be shown pertaining to each debug statement that we put in there. So the reason we reference them in the user script is that they're available through the whole experiment. So as I talked about with scope, you want to make sure that whatever you set is available either in the user script, which as I mentioned is like the global scope, or somewhere in the beginning, so that down in the trial levels you're able to access it. So we've actually set these warning messages in the user script so that we don't have to worry about referencing them at any level of the experiment. So whatever warning message needs to be displayed with the debug statement, it will be shown in the output window. So this is just a way to do that. The other statement we have is the debug.assert. Now, as debug.print can actually help with any problems logging values and things with what's referenced. You can actually use an assert statement, and this is useful for checking assumptions in script. Now what that means is it'll tell you why an error happened, and it'll make sure that everything's set correctly. So in this specific example, we have an assert statement here, and we want to just make sure that an object name is available. This is important. Let's suppose you're copying and pasting and you want to make sure that there is a reply slide. And here there's a reply slide. But if you copy and paste and it's called stimuli or something different, this assert statement will fire, meaning that it will let you know that the object name above is not in your experiment. So with debug.assert, it allows you to kind of know why an error happened, and then it also helps if you transfer over to your colleagues and they want to copy and paste, they can make sure that the objects and everything is set correctly. The other thing I want to point out is in the user script. Let's go back up to view and script. The user script is where this tab here is where you can actually type and add script for the global level, as I mentioned, which is what we've done here with these warning messages. The full script, which will be generated after you run, after you generate up here and then actually run the experiment, is basically all the script and coding available in the background of ePrime. So that's kind of what our developers have done in terms of setting ePrime up. So you probably don't really need to reference the full script. The user script is, like I said, where you can actually edit and add and change any script that you need on the global level. What I want to mention, if you are putting any warning messages in to use a debug statement, we recommend making sure that the message is very clear, just like anything with script. I mean, we use a lot of comments that's displayed here in the green, because very specific commentary is great practice for when you send an experiment over to a colleague, or years later when somebody may be looking at your research. You want to make sure that they know exactly why this line of script is there and what it's doing in your experiment file. Along with having very detailed comments, we recommend the warning messages or any of the debug statements, make sure they're very clear. You can see here that these are very specific in terms of, the inline function may not this inline may not function properly because the duration is not 0. That's a warning message that's pretty clear to understand. So it's good to have that set in detail. So these are actually really helpful if you're doing a specialized script. If you have something very specific that you want to set up, you just want to make sure, you'll see here that the words in yellow are basically set to a string, and then they're set as a constant. So the constant means that each time it's referenced in the script, it will be equal to the red line. So this constant allows this red line of this, basically the string of the warning message, to be displayed. So that's pretty much all I wanted to show for error handling. We do, as I mentioned, have an eBasic help, some information in there regarding creating custom error messages that will fire if you want to set something in your experiment. Now, the importance of debug statements, as I mentioned, it's error handling, so it'll help you with, what values are, what the variable is collecting, whether objects are set up in there correctly, or if something is missing. But it's not for syntax handling. And what that means is the way you actually write your script. If there's something typed incorrectly with your coding, debug statements will not handle that. For that, you would need to do the actual error handling that I mentioned before, which is compiling and generating line by line to make sure that the script is implemented correctly. Okay, so now that we've talked about debug statements, I'm going to open up the slide that answers the questions. So you'll see here that we've talked about the debug statements, and the general answer is that these are statements that can check if a script is executed correctly and what variables have been returned. And as I mentioned, it's error handling, not syntax handling. So if you actually have some issue with the syntax of your script, you should definitely go line by line to check what's missing or what's wrong. And then if you continue to have any trouble, you can send a support request into a consultant and they can take a closer look as well. And the next question was, when is debug.print used? As I mentioned, debug.print is to check a variable, and that will come out in the output window if you want to check something, such as a value, or let's suppose you're checking the total count of the trials and how many times it's ran. If you would like to see what's been added so far, you can put a debug statement, and that will show the value in the output window. And when is a debug.assert used? Well, that's used when you want to check an assumption in script, and it'll tell you why the error happened. So for example, in the sample we looked at, the reply slide is not available, or the duration is not set correctly, or something like that. It'll check and make sure that assumption is set correctly.